Hello students, till now we discussed about the potential difference, current, charge and everything, and now it's a time for us to discuss about the relationship between the potential difference and the current. So for that we have the big name, that is Ohm's law. This Ohm's law is the most important thing for you guys. Why? Because there may be a chances to come in between 2 to 3 marks based on that. Maybe the question, maybe the statement, maybe the formula, maybe the problems also. Clear? Let's get started with the Ohm's law. To see the relation between those two, you need to perform one activity. That activity which contains the nichrome wire, ammeter wire, and the potential difference along with the battery, voltmeter along with the battery, which we need to see. This is how the setup, the circuit, how they did here. So this is a nichrome wire, which is some particular constant of the resistance, which is end of this nichrome wire is attached with the voltmeter, and the next one is the ammeter here attached and plug key, and several batteries are there. And here just have a look, ammeter is attached or ammeter is arranged just series wise to the nichrome wire, and in the case of the voltmeter is attached parallel to this nichrome wire. Always you should remember this both two. And next, the first one, our task is to complete this table. How to complete this table? The table contains serial number of the cell used in the circuits. This is a 1, 2, 3, 4. The four different experiments we are going to do here now, and the current through the nichrome wire. So this nichrome wire, how actually the current is going to pass, which is calculated by the ampere, ammeter. That is the I. And the next one, potential difference across the nichrome wire. See this two end, how actually the potential difference is, which is calculated by the voltmeter, which we are going to mention here. This one is in the starting. I am just told that the relation between the V and the I we are going to measure. So V bar I we are going to write. Let's start with the first case. The first case says what you need to assume. I am just going to arrange only one battery here. Only one battery. At that time I am going to take the note down what is the reading on the ammeter and what is the reading of the voltmeter also. Ammeter I have the reading of I1 and the voltmeter I have the reading of V1. And the next I am going to attach with the 2. What I am going to do, I am increasing the number of the current passing through this nichrome wire. Okay, fine. So 2 battery I am going to attach here. Then this one comes I2. And here also increases to the V2. And the next case I am going to apply the 3 batteries. When I apply these 3 batteries, what happens? Here increases with the I3 and here also V3. Okay, only just here the current I am going to write here. Here the potential difference V I am going to write here. That's it. And the next one is the fourth one. I am going to attach the 4 battery here, and reading ammeter shows that I4 and the voltmeter shows that V4. And then what we have to do, and we have to compare, isn't it? So what we will get V1 by I1, V2 by I2, V1 by I1, V2 by I2, V3 by I3, and V4 by I4. This is how the common thing we are going to get here. And listen it carefully, my dears. What happens when current is increasing, when I am go on adding the batteries here, what happens? The potential difference or the volt also increasing. So can I say that I is directly proportional to the V? Okay, what do you mean by this proportional? Proportional always says that when I increases, voltage also increases, potential difference also increases. When I decreases, potential difference also decreases. Okay, this is how the proportionality says. And the next one, when I is indirectly proportional, in the sense what happens? When I increases, R decreases. When I decreases, R increases. Okay, this is how the proportionality, in the sense if this one increase, this will also increase. If this decrease, this also decrease. Inversely proportional in the sense vice versa. If it is increase, it is decrease. And here I need to observe you guys, that is V directly proportional to I. See this one, V is directly proportional to I in the experiment we just now did. And the next one is the formula V by I is equals to R. What we are going to get? R is the resistance. And then if we want to find out the V is equals to I into R, what we are going to get? Here just resistance, we have the new one. The old formula says that R is equals to V by I. This is how all about the formula and the Ohm's law. What is this R here? R says that resistance. Okay, what is this resistance now? Resist the flow of the charge. Nothing. The flow of the charge in the wire which will has the capacity to hold it or to stop it or slow down it. The resistance, stop it, what we are going to call it, that one is a resistance. And next one, this is how the final formula what you need to remember. And the voltage, see, voltage, current and the resistance, three factors here is there. So I want you to have a look towards this one. Why? Because there is a one important symbol is given for you guys, the voltage. When we are discussing voltage, the SI unit is volt, current SI unit is ampere, and resistance SI unit is ohm. This is the new one, ohm. And how we are going to represent this ohm? With a Greek letter, ulta cap. Okay, this is how Greek letter. And if you want to say in this, if you want to write this in the form of the SI unit, it is a, see, just replace this resistance R by ohm. 1 ohm is equals to volt, 1 E by I. See, 1 I. That's it. Okay, this is all about the Ohm's law. I hope I made you clear. Thank you.